Continuing with our course, the IB Mathematics standard level. Now we've reached to class number 12, which is integration, or this is the integral calculus. This is part of the calculus topic, or we can call it the antiderivatives. So to start with, if I'm having, say, f of x is equal to 3x squared plus 2x. And as we covered before, that if I want to derive this function to find the first derivative, to find f prime of x of x is equal to 6x plus 2. This is finding the derivation. So to go from f of x to f prime of x, we need to derive, which is differentiation. To go from f prime of x to f of x, we need to integrate. The opposite way, we need to integrate. That's why we called the integration as the antiderivative, because it's the exact opposite of differentiation. So let's see, by using graphical means, what do the integration or the antiderivative represent. Let's say I'm having this axis, and I do have this graph. This is, let's say, whatever the graph is. Let's have a quadratic function, maybe like this. This function is f of x. As you do remember that when I wanted to derive finding the first derivative, which is differentiation, the first derivative represented the function gradient of the tangent at any point, which means I'm finding the gradient of the tangent at this function at any point. That's what the first derivative means. But if I want to integrate this function, let's say I'm integrating this function from x is equal to 0 to x to this point, let's say, which is, let's call it a. So if I want to integrate this function from 0 to a for f of x, I will find the area under graph or under curve. So if I want to integrate, I will find this area in red. This is what integration gets me. So when I integrate, I find the area under curve, and when I use the differentiation or the first derivative, I do find the gradient. Let's continue. If I'm having f prime of x to be equal to x to the power of n, and I want to find f of x. So to change from f prime of x to find f of x, I need to integrate, which is the antiderivative. By integration, this is what I do. I add 1 to the n and I divide by the power, and I add a constant which is c. This is for undefined interval, or I have infinite interval, I add the c. I hope it's clear. Now let's do some links with deriving certain functions and how can I integrate, and I will show you it will be easy. Let's say I'm having f of x is equal to sine of x. So f prime of x is equal to cosine of x, as we discussed before. If I'm having f of x is equal to cosine x, then f prime of x is equal to minus sine of x. If I'm having f of x equal e to the power of x, then f prime of x is equal to e to the power of x. If I'm having f of x is equal to ln of x, f prime of x is equal to the derivative inside the ln over the same function inside the ln. So it becomes 1 over x. So now, this is how we derive. And the antiderivative is simply the opposite. So from f prime, the integration of cosine x is equal to sine x. The integration of minus sine x is equal to cosine x. So the integration of sine x is equal minus cosine x. The integration of e to the power of x is simply e to the power of x. And the integration of 1 over x is equal to ln of x. I hope it's clear till now. Let's now cover that if we want to integrate two functions multiplied by each other. To integrate two functions multiplied by each other. Just let me remind you of the product rule for derivation. If I'm having g of x is equal to v of x times u of x. So to derive, I want to find the first derivative of g. I use the product rule, which is v prime times u of x plus u prime of x times v of x. This is when I want to derive. In integration, don't do this. We don't have a rule which says I'm having a product rule. Don't do this. This is a big mistake. Like if I want to integrate, let's say v of x times u of x dx. Just someone telling me is integration of v of x times the function u of x plus integration of u of x times v of x. This is a very big mistake, and please don't do that. We don't have what is called of product rule while integrating two functions multiplied by each other. We don't have a quotient rule, and we don't have like the chain rule. Okay? So when we want to integrate two functions multiplied by each other, we have a method which is called the substitution method. So in order to integrate v of x times u of x, a function, dx, we need to use the substitution method. The substitution method is like we take one of the functions, we let it to be a u, we derive it, and we substitute some of the variables so we can get to a point we can integrate our function. So, using the substitution method, let's take an example on substitution method. I want to integrate x times the square root of 2x plus 5 dx. So now, first of all, I let the function inside the square of root to be u. So let's start. I'm having u is equal to 2x plus 5. Now I derive this function. So I'm having du over dx to be equal to, simply is equal to 2. So from here, I have that dx is equal to du over 2. Now, simply I substitute. That's why I call it substitution. I substitute the 2x plus 5 here, which is du, instead of the 2x plus 5. And I'm having dx is equal to du over 2. So I take the du over 2 and I substitute it instead of the dx. And still I'm having this x here. So what to do with this x? So from the beginning, I let u equal to 2x plus 5. So I can find the value of x here. So a little rearrangement in this equation, I'll have that x is equal to u minus 5 over 2. X is equal to u minus 5 over 2, and I substitute this value here instead of the x. Now my integral would be is an integration of u minus 5 over 2 times, we've said that 2x plus 5 is u to the power all of it of half, times, we've said that the dx is equal to du over 2 du over 2. Now I'm having my integral, all of it, in terms of u times du, so I can integrate. Let's continue. I have a half, a 2 in the denominator, and another 2 in the denominator, which makes me 1 over 4. I can get this 1 over 4 out of the integral since it's a constant. So this is equal to 1 over 4 times the integral, which is u minus 5 times u to the power of half du. Let's continue. So this is equal to 1 over 4 times the integral. U times u to the power of half is u to the power of 3 over 2 minus 5 times u to the power of half du. Now I can integrate. So it's a 1 over 4 times the integration of. This becomes add 1 u to the power of 5 over 2 multiplied by 2 over 5 because we need to divide by the power. When you divide by 5 over 2, you multiply by the reciprocal, so you have a multiplication by 2 over 5. Minus 5 u to the power of, we add a 1 to the half, it becomes 3 over 2. And we multiply by the reciprocal of the power as well, which is 2 over 3. Now I'm having is a 1 over 4 times 2 over 5 u to the power of 5 over 2 minus 5. I'm sorry, which is I can multiply by the 2 over 3 here. Let's erase it. 5 times 2, which is minus 10 over 3 u to the power of 3 over 2. This is equal to, when I want to get the 4 inside, it becomes u to the power of 5 over 2 over 10 minus 5 over 6 times u to the power of 3 over 2. Am I finished like this? Is like I'm all the way. Most of our work is finished here. But because our integral was in terms of x, I need to get my x back. So from the beginning, we let the u equals 2x plus 5. So simply, for my final integral, I plug the 2x plus 5 instead of the u. So I take the 2x plus 5 and plug it instead of the u. So my answer would be, my final answer is 2x plus 5, all of it, to the power of 5 over 2 divided by 10 minus 5 over 6 times 2x plus 5, all of it to the power of 3 over 2. And this is my final answer. This method is called the substitution method. This method is called the substitution method, and most of the time we need to find the value of integrals so we can find the area under curves for certain regions or whatever specified region in the question. And the last thing we're going to talk about is finding the volume if the area is rotated by 360 degrees around the x-axis. So to find the volume, simply we need to use pi times the integration. This is the region from B to A for y squared dx. We need to multiply pi times our integral for our function squared. Let me just discuss with you how can I find the volumes of, how are they related, that when we revolve the function around the x-axis, what can we get? Like if I'm having a triangle, let's draw our axis. let's say I'm having this triangle in here like this. I'm sorry, it's a rectangle. I'm having this rectangle. We'll discuss the triangle. Yes, we'll discuss it again. This is a rectangle. So simply, if I integrate the function normally, we can get the area. But what happens if I revolve this shape by 360 degrees around the x-axis, which is this one? So I'm having a revolving part resulting in, this is my axis here, and this is my axis. So the shape will be revolved like this. If you can see, by revolving a rectangle, we'll end up having a three-dimensional shape, which is a cylinder. So sometimes in the question, if it's given axis and it's given a rectangle, and the question asks for the volume of the cylinder drawn, what you all have to do is to multiply pi times the integral of the function squared for that finite region. Let's see a case if I'm having a triangle. Let's draw our axis first. And let's draw our triangle. Let's say I'm having this one like this. And I want also to do the same. I want to revolve this triangle around the x-axis. Let's see what the final shape will be. If I want to revolve it, I'll be having also, this would revolve like this, and this part would revolve like this. So the form three-dimensional shape after revolving this triangle is a cone. So you have to understand how the revolving of two-dimensional shapes by 360 degrees around an axis for these three-dimensional shapes, it's really important and essential to be able to imagine these shapes so you can answer your question correctly. Now let's have a question from the question bank. Let's see this example. Part A, find the integral of x times e to the power of x squared minus 1 dx. So part A, I want to find this integral x e x squared minus 1 dx. As you can see, I want to integrate having two functions multiplied by each other. So I need to find values for the u. So I can let the u to be equal to the x squared minus 1. This is my u. So I'm having u is equal to x squared minus 1. Let's derive this function. So we'll have du over dx is equal to 2x. Ending with that dx is equal to du over 2x. Now I substitute my values. So I take the du over 2x and I substitute it instead of the dx and the u instead of the x squared minus 1. So my integral will be, this is x e to the power of u times du over 2x. And as you can see here, the 2x cancels with the x. Most of these questions, or when you want to find integration by substitution, there must be a cancellation somewhere. So you make the function easier to integrate. So I cancel this x with this x, and I can take the 2 out. So my integral is now half times the integration of e to the power of u times du. Now I can integrate easily, as you can remember that the integration of e to the power of x is simply e to the power of x. So my integral now is half times e to the power of u. I substitute my values again, so my integral is half e x squared minus 1. This is my integral for part A. Let's do part B now. Find f of x given that f prime of x is equal to x times e to the power of x squared minus 1, and f of minus 1 is 3. Okay. What I found here is missing something, which is the c, the constant. So my integral is half e power of x squared minus 1 plus c. Always I need this constant. So in part B, the f prime of x is equal x e to the power of x f prime, and I need to find f of x. So in order to find f of x, I'm moving from f prime of x to f of x. So when I move the opposite way, I need to integrate. And we've already integrated this function. But the only step that's missing is to find the c, constant. And it's given here in the question that f of minus 1 is 3. It means that when x is equal to minus 1, the value of the function is 3. This is a coordinate. So I'm having half e to the power of minus 1 squared minus 1 plus c is equal to 3. I need to find the value of c. So as a half, this is a 1 minus 1 e to the power of 0 plus c is equal to 3. So now the value of c, simply half times e to the power of 0. This is a 1, which is a half. The value of c would be 3 minus half. So c is equal to 5 over 2. So now my f of x is equal to half e to the power of x squared minus 1 plus the c, which is 5 over 2. And by this, I've solved the question fully. I hope it's clear what we've explained in this lesson. I hope you got the links between the derivative and the antiderivative, the integrals of certain functions, the meaning of the antiderivative or the integration, which is finding the area under curve. If I'm having a volume, it will find me the volume by revolving that two-dimensional shape around the x-axis. And we've taken the substitution method because it's not like the derivative. We don't have what's called like the product rule or the quotient rule. We need, when we want to integrate two functions multiplied by each other, we need to use the substitution. And again, I have to remind you at the end of each class is you have to practice, and to practice.